So we're on page 13 of quadratics. Okay, so we're going to find the equation of the quadratics with the following graphs, okay? So this maybe think back to the investigation with the roller coaster and with the hills. And every time you see a quadratic, you're going to say, okay, which fits better, factored form or vertex form? So if they give you the vertex, you definitely want to be using vertex form, and if they give you the place where the x-intercepts are, then maybe you're going to be using factored form. Let's look at 1a. So in 1a, they give us two x-intercepts and they give us a y-intercept. So if they give us the two x-intercepts, then that's kind of a giveaway that we should be using factored form. And the two x-intercepts are 1, 2. So that means the factored form would be x minus 1 times x minus 2. Okay? And the only thing we don't know is what our a value is. Okay? So this is our function, y equals a times x minus 1 times x minus 2. And then we just need to figure out what a is. The way we figure out what a is we put 4, which is a y value, and the x value for this point. So basically, you know, this point is, the coordinates are 0, 4. So that means that at the point x equals 0 and y equals 4, this equation is true. So let's show that that is true by figuring out what the a value, which makes that true. So we're going to put 4 in for y, and then we're going to leave a unknown, and then for x, we're going to put 0. So we end up with something like this, right? And then we're going to simplify it, so we get negative 1 times negative 2 times a equals 4. Well, negative 1 times negative 2 is positive 2, so that means 2a equals 4, which means divide both sides by 2, and we'll get a equals 2. So our a value in this case is 2, so I'm going to rewrite the equation. It's going to be y equals positive 2x minus 1 times x minus 2, and we're done. What about B? So B looks like they give us the vertex and they also give us y-intercept. Okay, so if we use the fact that the vertex is 2, 0, then I could put it into vertex form, which would be x minus h squared plus k, right? And so in this particular case, we don't know what a is yet, but we do know that h is 2. And we do know that k is 0, so we don't even need to put anything else there. And now we can take the fact that the y-intercept is 0, 8 to plug in 8 for our y, and then 0 for our x, and that gives us 8 equals a times negative 2 squared. Negative 2 squared is 4. So it means 8 equals 4a, so a equals 2. So I can rewrite now my function with a equals 2 filled in. So it'll be y equals 2 times x minus 2 squared. Okay, so that's my equation for B. What about small c? So for this one, they gave us two x-intercepts, and they gave us a y-intercept of 0, 3. So let's put it in factored form, which remember is y equals a times x minus p times x minus q, where p and q are the x-intercepts. So in this case, we have a times x minus 1 times x minus 3. And let's see, now we're going to find out what a is by putting 0 in for x and 3 in for y, so we end up with 3 equals a times 0 minus 1 times 0 minus 3, which is equal to a times negative 1 times negative 3. So 3 equals a times 3, so a is equal to 1. So I can rewrite my equation now. It's going to be y equals x minus 1 times x minus 3. That's it. What about D? So D, they give us two x-intercepts, which are negative 1 and 3. That looks like we should put it in factored form then. So we're going to put y equals a times x minus negative 1 times x minus 3. Well, x minus negative 1 is x plus 1, right? So I'm going to rewrite that. and x minus 3 is still x minus 3. And then I'm going to take the additional point they gave us, which is the 0, 3 point, and I'm going to put 0 in for x and 3 in for y. So that'll be 3 equals a times 0 plus 1 times 0 minus 3, which is equal to a times 1 times negative 3, which is negative 3. So 3 equals a times negative 3, and if we divide both sides by negative 3, we find out that a is equal to negative 1. So then we're going to rewrite the function with everything filled in. So it'd be negative a times x plus 1 times x minus 3. For this next one, they give us a vertex at, it looks like it's at 1, 0. That's the vertex. And the y-intercept is 0, negative 3. So let's do it in vertex form. So we'll have a times x minus 1 squared plus 0. And then we'll put x equals 0 and y equals negative 3 into our formula. Oops. And so that gives us negative 3 equals a times negative 1 squared. Negative 1 squared is 1. Plus 0. So a is equal to negative 3. Now let's rewrite it with everything filled in. So it would be y equals negative 3 x minus 1 squared plus 0. Okay. Let's do f. So in this particular one, they give us two x-intercepts, and they give us the y-intercept, which is 0, 12. So we're going to write that the equation is y equals a times x minus negative 2 times x minus 3, which is equal to a times x plus 2 times x minus 3. And 0, 12 is a point xy that makes that true, so I'm going to put 12 equals a times 0 plus 2, which is 2, and 0 minus 3, which is negative 3, which is equal to negative 6a. Divide both sides by negative 6, and we end up with a equals negative 2. Number 2, find the quadratic with the graph. And here they gave us some different types of information. They gave us that the y-intercept is 0, 12. The x-intercept, one of the x-intercept is 2. The axis of symmetry is x equals 3. And from this, there's a lot of problems like this on the exam. Would you use vertex form or factored form? And when you look at this, you're like, well, I can't use vertex form because they only gave me the x-coordinate of the vertex. They didn't give me the y-coordinate of the vertex also. I can't use factored form because they only gave me one x-intercept. They didn't give me the other one. But you can see that with the axis of symmetry and one of the x-intercepts, you can figure out where the other x-intercept is by symmetry, right? So if x equals 3 is the axis of symmetry, and on the left side the x-intercept is 2, the right side the x-intercept must be 4, right? Because both of the x-intercepts need to be equidistant from the axis of symmetry x equals 3. So now I have both x-intercepts, and that means I can write my equation, which is going to be x minus 2 times x minus 4. And now I can use my point 0, 12 to figure out what a is. So I'll put 12 equals a times 0 minus 2, which is negative 2, 0 minus 4, which is negative 4, which is equal to 8a. And then if I divide both sides by 8, then I'll have a equals 12/8, which is equal to a is 3/2. And then if I filled in the a value here, it would be y equals 3/2 times x minus 2 times x minus 4. And then what about this next one? This next one is similar, right? They give us the axis of symmetry. They give us one of the x-intercepts. We'll be able to find the other x-intercept by reflecting it on the other side. So these are 3 units apart. So that means to find the right one, we add 3 to negative 1, which gives us 2. So in this case, our equation is going to be y equals x minus negative 4 times x minus 2. And so and our y-intercept is 0, 4. So we can use that to find the a value. So we could put 4 in for y, and then we'll put 0 in for x. So this will be x plus 4, right? So instead of x plus 4, we're going to have 0 plus 4, which is 4, and then we're going to have 0 minus 2, which is negative 2, which is equal to negative 8a. So that means that a is equal to 4 divided by negative 8, which is negative 1/2. So our a value is negative 1/2. So if I wanted to rewrite this function, I would write y equals negative 1/2 x plus 4 times x minus 2. What about C? So for C, I have an axis of symmetry at x equals negative 3. And oh, look at that. They didn't tell us what the vertex is, but they showed that it just touches the x-axis. So that means the vertex must be negative 3, 0. So actually we can use vertex form, right? So we'll have y equals a times x minus negative 3 squared plus 0. And we know that one of the points is going to be this y-intercept, which is 0, negative 12. So I can put negative 12 into the formula. So it'll be x plus 3 squared. And then I can solve for a. Oh, I can fill in 0 for x. So it'll be negative 12 equals a times 0 plus 3, which is 3 squared, which is 9. A times 9. And so a is equal to negative 12 ninths, which is equal to negative 4 thirds. And so if I want to rewrite the equation, I could rewrite it as y equals negative 4 thirds, negative 4 thirds times x plus 3 squared. Okay, so that's the answer for that one. This is the last one. Find in the form, and this is called standard form, y equals ax squared plus bx plus c, the equation of the quadratic whose graph, and then they give us 3 possible conditions. 3a says cuts the x-axis at 5 and 1 and passes through to negative 9. So 5, 1 would be the x-intercepts, and it gives us one other point that we could figure out what the a value would be. So let's do that first. So I'm going to first write it in factored form. So it'll be a times x minus 5 times x minus 1. And I know that this quadratic is going to pass through 2, negative 9, so I plug in 2, negative 9. So it would be 2 minus 5, which is negative 3, and 2 minus 1, which is 1. So negative 9 equals negative 3a. So a is equal to negative 9 divided by negative 3, which is positive 3. Now I'm going to rewrite the original function as 3x minus 5 times x minus 1. So that's my new function. But they want it in standard form. So I'm going to multiply everything out. So I'm going to have x squared minus 6x. I just did FOIL. Okay, minus 5x minus 1x is minus 6x plus 5. And then I'm going to distribute the 3. So I get 3x squared minus 18x plus 15. Okay. Now I'm going to do C. We're going to find a quadratic which touches the x-axis at 3, which means the vertex is at 3, 0, and passes through negative 2, negative 25. So we could write it initially as y equals a times, and then we'll put it in vertex form, and plus 0. And then we are going to find what a is by substituting x equals negative 2 and y equals negative 25. So we'll put negative 25 equals a times negative 2 minus 3 squared. So it'll be a equals negative 25 equals a times, and then negative 2 minus 3 would be negative 5 squared. So that will be negative 25 equals 25a. And a is equal to negative 25 divided by 25, which is negative 1. And so that means that the rewritten formula, or the rewritten equation, is going to be y equals negative 1 times x minus 3 squared. Last one. a quadratic which cuts the x-axis at 3, passes through 5, 12, and has axis of symmetry at x equals 2. So, if it has an axis of symmetry at 2, and it cuts the x-axis at 3, then I can see that the other x-axis would be at 1, right? Because 3 is 1 unit away from 2, and 1 is also 1 unit away from 2. So I know that the other x-intercept is going to be 1. Okay, so I'm going to write first in factored form. I'm going to put y equals a times x minus 1 times x minus 3. And then I'm going to put 5, 12 in here to figure out what a should be. So I'm going to put 5 here, and I'm going to put 12 here. So it'll be 12 equals a times 5 minus 1, which is 4, and 5 minus 3, which is 2, which is equal to 8a. So a is equal to 12 divided by 8, which is equal to 3 divided by 2. Oops. Um, 12 divided by 8, which is equal to 3 divided by 2. So a is equal to 3 halves. And now if I wanted to rewrite it, I would write 3 halves times x minus 1 times x minus 3. Yeah, I forgot to do something. Remember how I'm supposed to change it into standard form? So this one here, for example, I need to expand it. So it'll be negative x squared minus 6x plus 9. So that's equal to negative x squared plus 6x minus 9. And then this last one, I need to expand this, so it would be 3 halves times. It's easier to do the FOIL first. So we get x squared minus 4x, because minus 3x minus 1x is minus 4x, and then we multiply negative 1 times negative 3, and we get positive 3. And then we distribute the 3 halves if you want to. So 3 halves x squared minus 12 halves x plus 9 halves. And so maybe you can simplify the second term. The second term, instead of minus 12 over 2, you could put minus 6x, and I think the rest of it stays as is.